Hi, everyone. Welcome to this week's Science Podcast. Well, the International Meeting for Autism Research, or IMFAR, was last week, and there was a lot of exciting research presented from top experts in the field on everything from prenatal risk factors, early detection and diagnosis, interventions across the lifespan, biological markers, and even adult services. There's probably more that I'm missing. But instead of a summary that won't do the meeting justice, I urge you to go on the link on the ASF webpage to the Simons Foundation Autism Research Initiative news site, which was blogging daily from the meeting about the highlights. But meanwhile, while we were at the meeting, important scientific findings continue to be released, and these findings affect families with autism. One in particular interest is led by the University of Washington. This study followed up on children who received an early intervention for autism symptoms. You may remember this study. In 2010, Geraldine Dawson, now at Duke, published the first randomized clinical trial on the efficacy of what was called, or is called, the Early Start Denver model. And at the time the treatment had ended, they found gains in cognitive functioning and expressive and receptive language, as well as improvements in adaptive behavior, but not on autism symptom level. Very few studies of these kinds are going any farther out into development past the end of the initial study. The assumption is that if a child is improved at 3 years, then things are going to continue to stay or continue to improve. We don't really know if this is true, and we don't know what type of interventions or supports these kids may get afterwards. But now there's scientific evidence to support both the short and longer term effects of this intervention. I asked lead author Annette Estes what the study was about.
Disorder, all of whom began participation in a randomized clinical trial when they were 18 to 30 months of age. Followed them up when they were 6 years old. And initially, everyone was randomly assigned either to community intervention as usual or intervention with the Early Start Denver model. And intervention with the ESDM was conducted for 2 years. People got about 15 hours a week of one-on-one intervention. And we're asking, how are the kids doing 2 years later when they're 6 years old? So surprisingly, there was only one other study of long-term outcomes for children after engaging in a comprehensive intervention for autism. And it was published more than 20 years ago. And the study, in fact, it was the very first long-term outcome study of a randomized clinical trial for very early intervention. Ours was. And again, that was surprising to me. And what we found was that the ESDM group, on average, maintained or increased the gains that they had made in early intervention over the follow-up period. So that includes overall intellectual ability, adaptive behavior, symptom severity, and challenging behaviors. So this was important to show that kids maintained or improved because people had been concerned that there may be a regression or loss of skills after intensive intervention is ended. And we didn't see that at all. In fact, some of the group differences that were seen at 4 remained. And also we saw gains in areas that we didn't see at the end of treatment when kids were 4. So at 4 years old, right after treatment, no group differences in core autism was found on the ADOS. But at 6 years of age, we did see significant group differences, with the ESDM group having improvements or reductions in their core autism symptoms. I think the take-home message here is that intensive autism intervention does lead to long-term gains in children with autism.
So what should clinicians and families know? First, early intervention works, both in the short and longer terms. Children are able to maintain the gains they made even after a reduction in services when the study was over. The reduction, of course, is when this really intense early intervention service study was over. And even more promising is that these gains may generalize to new domains because ASD symptom severity was reduced 2 years after the intervention ended, something that was not seen in the earlier study. So now what? Research is needed to extend these results to a more diverse range of families and communities to make sure that it can be effectively delivered in autism communities. In other news, I think that there's a general agreement that females with autism and gender differences in autism are understudied. As a co-sponsor of last year's Gender Differences meeting, ASF recognizes this as an important issue. So I am very happy that an entire journal issue is dedicated to this topic. A new issue of Molecular Autism will have 2 special issues on this topic, the first which was published last week. What's really exciting is that Molecular Autism is open access, which means that the Individual studies can each be downloaded for free by somebody who's online. So some of the findings that were reported in this select issue of the journal were also highlighted at IMFAR. For example, Christine Nordahl at UC Davis compared males and females with autism and included males and females without autism as comparisons. This is rarely done and clearly important, as while there was no straight out differences between boys and girls with autism on symptoms, girls with autism deviated more from typically developing girls than boys with autism deviated from typically developing boys. She went on to look at the structure of the brains of these toddlers and found that the corpus callosum, the area of the brain that connects the two sides to each other, they project differently to different areas of the brain in boys and girls. These differences were only seen when boys and girls with autism were compared to boys and girls without autism, further solidifying the notion that you can't just compare boys and girls without understanding how boys and girls without autism differ. So why are there differences in the prevalence between males and females? Some scientists are attributing this to what's called the female protective effect. This is a theory that there is a mechanism protecting the developing female brain from autism, and I think you've heard me talk about this before. Wouldn't it be simple if there was one single thing, whether it was a gene or a hormone or something else, acting as a protective factor? We could bottle it and share it with the world. In order to find if there was one gene, a study led by University of California, San Francisco, Washington University, and Yale School of Medicine analyzed the genetic data from over 4,500 families affected by autism. Their work disappointingly found that there is no single gene associated with the protective effect. The authors conclude that the mechanism of this protection remains unknown, but it's most likely regulated by multiple genes or other factors. The entire issue is free through Molecular Autism's open access policy and available by clicking the link from the ASF homepage or from the YouTube page. Thank you again for listening, and I'll talk to you next week.